Greetings, welcome to this new video about superposition theorem. Solve the problem number 11. In this video, I will demonstrate the application of the superposition method to solve a problem, and I will guide you through the step-by-step process of using superposition to solve the problem at hand. Let's consider this network consisting of two resistors labeled R1 and R2, as well as two independent sources IA and IB. Additionally, we can observe a dependent source, especially a voltage-controlled voltage source. The question now to use superposition method to find the voltage Vx across the resistor R2. Let's move on to the solution. First, we begin by identifying each independent source in this network. This step provides a clear understanding of the sources that will be analyzed separately. In this circuit, we can observe two independent sources, IA and IB. Both sources are independent current sources. Next, we proceed to deactivate all but one independent source in the circuit. This involves replacing the inactive voltage sources with a short circuit, which means it's zero voltage, and the current sources with an open circuit, which means it's zero current. Let's begin by activating the independent current source IA and deactivating the independent current source IB, which will be replaced by an open circuit. In order to calculate the voltage V1 across the resistor R2, we are going to use Kirchhoff's law. Let's consider first I1 is the current through the resistor R1 and I2 is the current through the resistor R2. By applying Kirchhoff's current law at node 1, we can write IA is equal to I1 plus I2. And if we replace IA with its numerical value, we obtain 10 is equal to I1 plus I2. Let's move on now. By applying Kirchhoff's voltage law in the outside loop, we can write negative R1 I1 plus R2 I2 plus 4V1 is equal to 0. And according to Ohm's law, V1 is equal to R2 I2. And if we replace V1 with R2 I2 here and we replace the resistors with their numerical values, we obtain negative 10 I1 plus 40 I2 is equal to 0. Now, by performing 2 plus 10 I1, we derive one equation in terms of I2. That means I2 is equal to 100 over 50. We get 2 amps. And the voltage V1, according to Ohm's law, is equal to R2 I2. And if we replace R2 and I2 with their numerical values, we obtain V1 is equal to 16 volt. Now let's consider the independent current source IB active and the independent current source IA inactive, which will be replaced by an open circuit. In order to calculate the voltage V2 across the resistor R2, we are going to apply Kirchhoff's laws. First, let's consider I1 is the current through the resistor R1 and I2 is the current through the resistor R2. By applying Kirchhoff's current law at node 2, we can write IB is equal to I1 plus I2. And if we replace IB with its numerical value, we obtain 4 is equal to I1 plus I2. Now, by applying Kirchhoff's voltage law in the outside loop, we can write negative R1 I1 plus R2 I2 plus 4V2 is equal to 0. And we know, according to Ohm's law, that the voltage V2 across the resistor R2 is equal to R2 I2. And if we replace V2 here by R2 I2, and if we replace the resistors with their numerical values, we obtain negative 10 I1 plus 40 I2 is equal to 0. Now, by performing 4 plus 10 times 3, we get 50 is equal to 50 I2 is equal to 40. That means I2 is equal to 40 over 50. We get I2 is equal to 0.8 amps. And according to Ohm's law, we said that V2 is equal to R2 I2. And if we replace R2 and I2 with their numerical values, we obtain V2 is equal to 6.4 volt. After completing the analysis for each independent source while treating the other as turned off, the subsequent step is to combine the results algebraically. This process enables us to determine the overall circuit response. That means Vx is equal to V1 plus V2. And if we replace V1 and V2 with their numerical values, we obtain Vx is equal to 22.4 volt. After completing the calculation, we conduct a simulation using a SPICE simulator in order to verify our result. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here the first network only the independent source IA active, and the second network is only the independent source IB active, and this is the complete network. Let's move on to analysis. This say analysis calculate nodal voltage. We can see here V1 is equal to 16 volt, V2 is equal to 6.4 volt, and Vx is equal to 22.4 volt. After completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves a validation of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about superposition theorem. Take care and bye-bye.